Today, we'll be looking at Arrhenius equation. First of all, we should know that for a reaction to occur, there are two conditions for it to occur. One is the minimal activation energy. Energy must be applied to the reactant for it to produce a product. And this energy is called the activation energy. Secondly, is the effective collision between molecules of the reactant. If there is no effective collision, it means product will not be formed. So, Arrhenius is trying to relate the rate constant of that reaction with the frequency factor, which is what? The collision frequency. Now, Arrhenius says, using an equation, that K is equals to E raised to power activation energy all over T, where the K represents the rate constant. The A represents the collision factor. It can also be called collision frequency. The EA is called the activation energy. And this activation energy is measured in kilojoules per mole. Then we have the T. The T is absolute temperature. And you know absolute temperature is that it is measured in Kelvin. Then don't forget we have a constant, which is the molar gas constant. The molar gas constant have a constant value of 8.314 joules per mole. Having it in mind that the molar gas constant have a fixed value of 8.314 joules per mole, then how can we now apply this Arrhenius equation? Arrhenius is telling us that for it to be on a straight line graph, it means we have to introduce a natural logarithm, which is normally called ln. The whole essence of introducing ln is to remove the exponential. Therefore, we will have ln k equals to ln a. When e meets with exponential, it cancels out and it becomes EA all over RT. If you arrange this equation, you will have ln k is equal to minus EA over RT plus ln A. This simply implied that according to the straight line graph, which is y is equals to ms plus c, it means ln k is automatically the y-axis. And s is what? 1 over t, because EA over R is not a variable but a constant. Then our intercept becomes our ln A. Therefore, the equation can be written as ln k equals to minus EA over R times 1 all over t plus ln A. Therefore, y becomes ln k, x-axis becomes 1 all over t, then your n, which is the slope from the straight line graph, becomes minus EA over RT, while C, which is your intercept, becomes ni A. So, it therefore means that when the temperature varies, that means when the temperature changes, the rate constant will also what? Change. Therefore, we will have ni K2 over K1 will become minus EA over R into bracket 1 all over T to minus 1 all over T1. It can also be rearranged as ni K2 all over K1 equals to EA all over R to give us 1 all over T minus 1 all over T2. Some of us may get confused. Why is the minus sign not there? Remember that the temperature increases. By the time we put an increased temperature, that is why we have in bracket T2. It will subtract from what? 1 all over T1. And you will get a positive answer, and that remains what? Negative. But in this case, by the time we put T1 here, T1 is a lesser temperature than what? T2. If you subtract, you get a minus answer. The minus will multiply by the minus here, and you will get a positive answer. It can also be rearranged as ni K1 all over K2 equal to minus EA all over R into bracket 1 all over T2 minus 1 all over T1. Now, the definition of the terms in Arrhenius equation. From this equation, K varies, that is the rate constant, varies with what? Activation energy. If the rate constant increases, it means your activation energy will decrease, and that will lead to the temperature increasing. So it is better understood when we use an arrow to represent this. So K is rate constant, EA is activation energy, and T is absolute temperature. And I said, if K is increasing, activation energy will decrease and temperature will increase. If K is decreasing, the activation energy will increase and T will decrease. That summarizes the Arrhenius equation. We are going to take some examples as regards this Arrhenius equation. Example 1. A table was given to us, and we have the temperature 25 degrees Celsius. The rate constant was also given to us at that temperature. 45, we also have the rate constant. Now, what is the question? The question is, calculate the activation energy for the decomposition of dinitrogen peroxide at different temperature. So the temperature they are telling you now is this temperature. So from the question, we were able to deduce the formula. And remember that I said the minus sign here can only be there if your T2 is subtracting your T1. But since your T1 is subtracting your T2, there is no minus sign there. So, when you have computed the value, you will have ni 2.253 is equals to EA over 8.314 times 2.1 times 10 raised to the power 4. Now, you will now try as much as possible to make EA the subject of the formula. And how do you do that? You simply cross multiply. When you cross multiply, you will have 0.81 times 8.314, which is equal to 2.1 times 10 raised to the power minus 4E8. Make E8 the subject of the formula by dividing through with 2.14 times 10 raised to the power minus 4. You will have your E8 to be equal to 32068.3 joules per mole. And if you were to present your EA in kilojoules, it means you will now convert this by dividing by 1000 to get kilojoules. Okay, we are going to do example 2. This example 2 is to show the graph of the Arrhenius equation. The question is, calculate the rate constant for the decomposition reaction of acetaldehyde. When acetaldehyde decomposed, they said it gave us methane gas and carbon monoxide. This reaction were measured at 5 different temperatures. The data are shown in the table below. Determine the activation energy in kilojoules per mole for this reaction. Now, this is the table given to us. We still use Nikkei solution. Since we are given table, the first thing that should come to our mind is the formula, which is Nikkei is equals to minus EA over R times 1 over T plus Ni. The question is determine the activation energy. It means it is from the graph we can determine the activation energy. And what are the things that are involved in the graph? The values. We said according to the straight line graph, y ms plus c, which is the straight line graph equation, y, which is the y-axis, is equals to Nikkei, and m is equals to EA over R minus EA over R. The x, which is the x-axis, is equals to 1 over T. And you know 1 over T is not given to us in this table. Nikkei also is not given to us in this table. So it means you have to draw a new table. What is K? K is 0.011, 0.035, 0.105, 0.343, 0.789 with their corresponding temperature. So you're going to get your calculator and type your Ni We also do that for 1 over t, and we have these values. Now the graph. Although we don't have a graph here, we will use the board as an arbitrary graph. Plot a graph so that we can be able to determine the activation energy of the question. To plot a graph, take a straight line. Vertical line indicates the y-axis, and according to the equation, the vertical line, which is the y-axis, is represented as ln k. Then the horizontal line is the x-axis, and according to the equation, the horizontal line is 1 all over t. So here will become our 0. We'll be starting our 0.0. We are going to take the line in 1 centimeter. 0.0 to 1.0 minus 2.00 minus 3.00 minus 4.00 and minus 5.00. Then for the x-axis, because our lowest value there is 1.2, 0 times 10 raised to the power minus 3. So we are going to take with 1.2. 1.2 times 10 raised to the power minus 3. 1.3 times 10 raised to the power minus 3. 1.4 times 10 raised to the power minus 3. The first value is 0.23. So we are going to do an arbitrary value from 0. Cool. Now we have plotted the graph. Then we will now take two values from the points that meet that in the straight line graph. You take two. One will be the y and x. Then the y have the corresponding x value, and the other y will have the corresponding x value. So using the formula, we can now calculate for our slope. Slope is delta y over delta s, and that is y2 minus y1 all over s2 minus x1. So from this our graph, we have y2 to be minus 3.4 and y1 to be minus 0.24. When you have put them into the formula, you will now have your slope to be equal to minus 18588.235. Remember that from this equation, our slope is equivalent to minus EA over R, and that is what we have. So we know that the EA is the activation energy. Impute the value of your slope, impute the value of your R. Your R is your molar gas constant of 8.314. When you cross multiply, you will have your activation energy in joules per mole. Remember that the question says in kilojoule per mole. It therefore means that we will divide this by 1000 to get 154.54 kilojoules per mole, while the minus sign is being cancelled out in the equation. Thank you. Please don't forget to like, comment, and subscribe.